Hi guys, today we're going to be working on 10-2, part 2. It's April 8th. Today we are going to be rationalizing the denominator. When we rationalize the denominator, that means that we're getting rid of the radical. Or the square root. Our examples today are going to look like 3 and then maybe 5 plus the square root of 2 in the denominator. So we can't just do what we did yesterday because there's two terms, right? We have a binomial down here. So if we were to multiply everything by the square root of 2, we would have 5 and the square root of 2. We would still have a radical down here. So instead, we want to use the conjugate, which is a fancy word of basically saying the opposite, right? We're going to be using the same numbers. We're going to use the opposite sign, okay? So if we have, which we do in our first example, 5 plus the square root of 2, then 5 minus the square root of 2 are examples of conjugates, okay? These two are conjugates because they're the same numbers but the opposite sign. The reason that we want to use the conjugate is if you bounce back, when we were multiplying binomials and we had the difference of squares, right? So separate from today, when we did A plus B times A minus B, right? And remember, there were all the methods, whether you chose box or you distributive or FOIL. If I do FOIL really quick, just to remind us, F is the first in the parentheses, so that's A times A squared. O is the outside, right? The outside rainbow, so A times B, so AB. I is the inside part of the rainbow, so B times A, which is AB again. The first one is negative because it's A times A negative B, so our answer is negative. And then lastly, we have B times negative B, which gives us negative B squared. And the middle always falls out, right? That's the whole point of the difference, is one you'll have the positive, and one you have the negative, and then they cancel each other out, and you're left with just the beginning and the end. So just A times A and B times B. A times A is A squared. Oops, sorry, negative. And B times negative B is negative B squared. So this is what we're doing when we're trying to find the conjugate. Okay, that same math. So here, when we multiply by the conjugate, we're going to do that on the top and bottom because twin rule. Whatever we do to one, we have to do to the other. So we've got 5 minus the square root of 2. And when we multiply, that means 3 times 5 is going to be, the 3 on the outside is distributed to both on the inside, right? So if we just focus on the numerator for right now, 3 times 5 is 15, and 3 times a negative square root 2 is negative 3 root 2. So that's our top. So then when we do the bottom, right, remembering what we did here, all we need to do is multiply the beginning and the end. So 5 times 5 is going to give us the 25. And then we have a positive square root of 2 and a negative square root of 2. So that gives us negative 2. which 25 minus 2 is 23. And now that we don't have a radical on the bottom, there's no square root sign, we're finished. Okay, let's do another one. Let's say this time we have 8 in the numerator and then 3 plus the square root of 3 in the denominator. So we want the conjugate, we want the opposite. So in this case, 3 minus the square root of 3. We need to remember the twin rule, so it goes on the top and the bottom, right? This is just a fraction equal to 1, the same thing on top and bottom. And when we multiply 8 times 3, we get 24 minus, and then 8 times the square root of the negative square root of 3 is negative 8 square root 3. And then on the bottom, when we multiply the first and the last, we get 9 minus 3. So here we get 24 minus 8 square root 3 over 6. Now, in this one, we're not finished. This one is different from this first example because 6 goes into, it has factors that are the same as 8 and 24. So it can be reduced, right? So when we reduce it by both numbers. So 2 goes into both of these, all three of these, right? So 2 goes into 6 3 times, 2 goes into 24 12 times, and 2 goes into 8 4 times. So we're left with 12 minus 4 square root 3 over 3. And even though 3 goes into 12, it does not go into negative 4. So this is our final answer. Okay. You ready to try one? Here's yours. You try. Let's say you have 5 over the square root of 7 plus the square root of 3. I'm going to solve this quietly. For this one, you should end up with 5 square root 7 minus 5 square root 3 over a denominator of 4. If you need to retry it or take a look at the examples, you should. If you're feeling ready, today's homework is same page, 631, 18 through 32 even, 38 through 42 even, and then 43 through 48. And this section is all. This is the section that's new today. These are the same as yesterday. Okay? Good luck.